Hi, my name is Courtney Hoffman. I want to go to college to major in biology and then later go into medical school for orthopedics. And then right now I'm a member of NHS and the volleyball team.
Hi, my name is Caleb Linden Smith, and I want to go to college somewhere out of state to major in pre-medicine and then go on to medical school to become a dermatologist. Currently, I'm a member of National Honor Society, the volleyball team, and we all did a Westinghouse Young Engineers program this past summer.
Hi, my name is Marissa Sharp, and I want to go to college for biology and then go to medical school or veterinarian school to either be a dermatologist or a vet. I am currently a member of Red Cross, SCA, and the swim team.
So just to give a little background on our project of the heart valve. So we were given a 17-year-old female patient who had an atrial ventricular septum defect, and she was in need of a mitral valve for her heart. So that was our goal.
Marble and wire in the rubber glove that's up here. There's a little hole, so whenever it's going this way, the marble covers the hole, and then whenever the water has to go this way, it actually goes through because the hole isn't covered by the marble. But as I showed earlier, whenever it's flipped this way, the marble covers the hole so the water can't get through.
For our prototype, we used the rubber glove on the bottom and we put a hole in the bottom so it's easily covered up by the marble. And then the marble acts as something that moves so that whenever water is flowing, it can easily move out of the way of the water, but whenever the water is flowing this way, it would cover up the hole. And then the top for the cage, we just use paper clips to hold the marble still in place so it wouldn't fall out of the valve.
Okay, so now we're going to demonstrate it. When you hold the heart valve prototype this way, water coming from this way should not travel through because the marble is down on the glove blocking the hole. So I'm going to demonstrate that right now. No water got inside, so that's a good sign. It's all just running around it because the marble's blocking. Okay, so now that you saw the demonstration where it blocks the water from coming through, we're gonna do it the other way, and the marble is sitting down on this metal cage, so the hole is open, so the water should run through it. There's the flow. It's pretty steady. Okay.
So some of the biggest problems we had with this lab was the actual construction of the prototype. So we had a few earlier design plans which ended up not working or breaking. In the end, we just ended up with a kind of simpler kind of thing. It seemed as if we overthought our design in the beginning, but then we ended up having like this very simple, but it worked. So one of our earlier designs actually broke, and then the second one didn't work and the marble got stuck. We had holes in the rubber gloves, the hot glue wasn't working, and our wire wouldn't bend correctly.
Okay, so just to elaborate on some of the problems that we ran into that Marissa just stated. So this was our first brainstorm drawing. So you can see we tried to tape the glove in there wrapped around a straw, and the straw was going to be the hole that the marble covered. But the hot glue actually kind of melted the glove, and it didn't, like, it had holes in here, so the water just kept running through, and the marble didn't create enough seal on this straw. So we went in and we put more hot glue on it, and that's whenever the marble got stuck. And then also the wires, they were just like, we kind of drilled little holes in the plastic tube to create the wires at an X, and they weren't really staying either. So that's why we came up with our second idea that we just presented to you.
Okay, if you guys have any questions, just email us if you have any questions on our prototype or any biotech questions in general.
Thanks for watching!